Hello students, in last lecture we have seen standard 10th subject science and technology part first unit number second, that is periodic classification of element, and in that unit we have seen Mendeleev's periodic table in last lecture. In that we have seen that the Mendeleev's periodic law, which is based on atomic mass of element, that is chemical and physical properties of elements are periodic function of their atomic mass. So this topic we have seen at last. Now today we are going to teach a next point, that is modern periodic table. So today's our point is modern periodic table. Now see, in 1913 English scientist, in 1913 English scientist, that is Henry Moseley, the name of that scientist, Henry Moseley, he showed that the atomic number of an element is the most fundamental property and not the atomic mass. So this scientist Henry Moseley, he showed that the atomic number of element is the most important or most fundamental property of element and not atomic mass, which was given by Mendeleev. So according to Mendeleev's periodic law, accordingly Mendeleev's periodic law was modified into modern periodic law. So Mendeleev's periodic law now converted into a modern periodic law, and that law is given as the chemical and physical properties of elements. See, the chemical and physical properties elements are periodic function of their atomic number. In Mendeleev's, the word or the atomic mass concept is used, but in modern periodic table, the scientist Henry Moseley, he showed that the atomic number is the main fundamental property of element and not atomic mass. So he stated the modern periodic law as the chemical and physical properties of elements are periodic function of their atomic number, not atomic mass. So atomic number. The periodic table based on this modern periodic law, which is known as a modern periodic table. See, which is known as a modern periodic table. So the table which is based on this modern periodic law is called as a modern periodic table. And what is that periodic law or modern periodic law? So the law is given as the chemical and physical properties of elements are periodic function of their atomic number. So this is called as a modern periodic law, and the periodic table which was based on this law is called as a modern periodic table. So this modern periodic table, it is also known as a long form of modern periodic table. It is also known as a long form of modern periodic table, which was given in this chart. You can see here, this is the long form of modern periodic table. So this table was based on the modern periodic law, in which the atomic number is the most important property of element which was used. So this is about the concept of long form of modern periodic table or modern periodic table. Now we have to study this modern periodic table. So in this modern periodic table, all elements are arranged in increasingly order of their atomic number. So you have to observe this table. In this table, we have seen here there are 7 horizontal rows which was known as periods. So in this modern periodic table, now we have to study this structure of this modern periodic table. Modern periodic table. So in this modern periodic table, the elements are arranged in order of their increasing atomic number. So this is the first thing, that is, the elements are arranged in order of their increasing atomic numbers. So first point is increasing atomic number. Now second one, in this modern periodic table, if you observe this modern periodic table, you can see in your book there is also this modern periodic table is given. So there are 7 horizontal rows, and that rows are called as a period. So second thing is periods, that is 1 to 7. So 7 horizontal rows are given in this modern periodic table, which was known as a periods, and their numbers are 1 to 7. Similarly, there are vertical columns. You can see here there are 18 vertical columns are given in this modern periodic table, and these vertical columns are known as a group. So next, group. So group, there are 18 groups are present in this modern periodic table. Now the arrangement of the periods and groups results into a formation of boxes. See here, you can see here the arrangement of these horizontal rows and vertical columns. They form a boxes, and in each box there is a element, single element is given. So now each box corresponds to the place for the each element. Then there are 2 series of elements. See, in this table, if you observe this modern periodic table, in this table there are 2 series of elements which was given below this table. So there are 2 series of elements which was placed separately at the bottom of this periodic table, and these series are known as a Lanthanum or Actinum series. So these elements are these series are known as a lanthanide or actinide series. Actually, this series was included in this modern periodic table. If you observe this, in this table there is a star mark is given. So first star, that is known which indicates the lanthanide series elements, and second star which indicates the actinide series elements, and these elements are shown below this periodic table. So in this way, this is the modern periodic table. Now in this modern periodic table, there are 118 boxes are there, as we have seen that due to the formation of these periods and group. there is a formation of boxes, and in this modern periodic table there are 118 boxes are there, and each box indicates one elements. So 118 elements are placed here. So out of this 118 elements having atomic number 92, that is atomic number 1 to 92, that is uranium. So up to the uranium, these elements are naturally found, and after that, that is from 93, atomic number 93 to 118, these elements are man-made elements. So this is the information about this modern periodic table. Now next point, in this modern periodic table, if you see, there are some blocks are given. These elements are divided into blocks, and these blocks have specific names. Now we can see these blocks. Now first, the elements in this modern periodic table, they are divided into 4 blocks. So in this modern periodic table there are 4 blocks. Name of that blocks are, see in this modern periodic table or in this chart you can see here, S block, then P block, D block, and F block. Now see in this chart, this first and second, these groups are form a S block. That is, in S block, the group first and second are included. Group first and second are included in S block. So group first and second, they form a S block. Now P block, that is from group 13 to group 18. These all elements are included in the P block or P block elements. So in P block, it includes group 13 to 18. So these elements which was present from group 13 to group 18, these all elements are included in the P block. Then from group 3 to 12, so the elements which are present from group 3 to group 12, these form a D block. So in D block, it includes the elements from group 3 to 12. So group 3 to group 12, this is called as a D block. And last one is F block. That is, we know that the two series present at the bottom, which was present at the bottom of this periodic table, which was known as a F block elements, that is actinide series and lanthanide series. Both are included in F block. So F block includes lanthanide and actinide series element. So in this way, these elements in modern periodic table, which was divided into 4 blocks, out of which S block, which includes the elements from group first and second. Then P block having elements from group 13 to group 18. Then from group 3 to group 12, these elements are included in D block. And at the bottom of this modern periodic table, there are two series, that is lanthanide series and actinide series, which was included in the F block. So in this way these all elements are divided into 4 blocks. Now in this chart or in this chart you can observe that the D block elements, see these D block elements, they are also called as a transition elements. See, D block elements, they are also known as a transition elements. Now you will observe that in this chart there is a zigzag row is given. In your book you can observe that zigzag line is given. So that zigzag line which was seen in P block of the periodic table, that is in this block, this line, see this line, this zigzag line which was seen in this P block of periodic table. So this zigzag line, what it indicates? Left side of this zigzag line all elements are metal, and right side of this zigzag line all elements are non-metal. And elements which was present on this zigzag line, that is boron, silicon, germanium, arsenic, antimony. So these elements which was present on this zigzag line, they are called as a metalloids. They are called as a metalloids. So this zigzag line, which indicates that in this modern periodic table, the elements which was present on the left side of this zigzag line, these are all metals, and right side of this zigzag line, these elements are non-metals, and elements which was present on this zigzag line, that is boron, silicon, germanium, arsenic, antimony, polonium. So these all elements are known as the metalloids. So you know metalloids, elements which shows properties of metal as well as non-metals are known as a metalloids. So in this way, this is the structure of this modern periodic table. Now next one. So we seen that the D block elements, that is elements present from group 3 to group 12, these D block elements are known as a transition elements. So why it is known as a transition elements? Because in this periodic table, if you observe that in this elements from left to right, if you see, that is lithium, barium, then boron, carbon, nitrogen, oxygen, so as. If you can see that from D block elements, that is from group 3 to group 12 elements, if we go from left to right side, the metallic properties of these elements, decreases gradually, and after this zigzag line they are converted, or properties of non-metals are seen. So D block elements are called as a transition elements. D block elements are known as a transition elements. Why they are known as a transition elements? See, if you observe this table or modern periodic table, you can see here from HS block to P block, that is from left side to right side. If we can move from left to right side, we can see that the metallic properties of elements decreases. Metallic properties of elements decreases. That is, characters of the metals are transmitted or decreases from left to right side. So there is a transformation of the metallic properties into non-metallic properties. So we can observe these elements here. So these D block elements are known as a transition elements, because in D block the metallic properties, while we are moving from left to right side of these elements, you can observe that the metallic properties are decreases, or they are transmitted into metals and then non-metals. So they are known as a transition elements. Now next point, that is modern periodic table and electronic configuration of the elements. So next point is modern periodic table and electronic configuration of element. So next point is modern periodic table and electronic configuration of elements. So before we start this point, you must know the element which was present in first two groups and three periods. So at least you know the name of these elements and their atomic number. So you must remember these names of the elements which was present in these first three periods and first two group, which are very important. Now you can remember the name of these elements in easy way. There is one trick to remember the name of these elements and their atomic number. So we can see that trick, or you have to remember that words. So what is that trick? You must remember the word hi, hello, life became bore, core, nor, all, found, new. So what is that line? Hi, hello, life became bore, then rhyming words are there, bore, core, nor, all, for, new. See, it includes the elements which was present in two periods, that is hi, hello, life became bore, core, nor, all, for, new. All, for, new. Then third period, that is Nathu, Mangu, all, silly person, surrounded, cloudy, army. So Nathu, Mangu, all, silly person, surrounded, cloudy, army. So in this way, by using this trick, you can remember the elements which was present in three periods. Now atomic number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 and 18. So with the help of this trick you can remember these name of elements with their atomic number. So very easy trick is there, that is hi, hello, life became bore, then rhyming word core, nor, all for new, nathu, mangu, all silly person, surrounded cloudy army. So by using this trick you can remember the name of the elements which was present in 3 periods. Now you have to also remember the names of elements which was present in the first 2 group. Now we can see what is trick for that. So this was important. Now you can remember the names of elements which was present in first 2 group or S block elements. There is also a trick. See, first group which includes the element, that is hydrogen, lithium, sodium, potassium, then rubidium, cesium and francium. So this is group first. So these are the names of the elements present in group first. Now in group second, beryllium, then magnesium, calcium, strontium, barium, and last one is radium. So these are the elements present in the group first and second. Now there is one easy trick. By using that you can remember the name of these elements. See, Helena की रब से फरियाद. See, first line is Helena की रब से फरियाद. Now say next group, बेटा मांगे कार स्कूटर बाप राजी. So you can remember the elements which was present in these groups by using this simple trick, that is Helena की रब से फरियाद, बेटा मांगे कार स्कूटर बाप राजी. So by using this trick you can remember the elements. So our next point, that is electronic configuration of the elements. So you know what is electronic configuration. We will see some examples. In your book there is one question, that is write the electronic configuration of the first 4 elements of group first. So in group first there are, see, hydrogen, lithium, sodium, like these elements are there. So while writing the electronic configuration you must know the atomic number of these elements. So atomic number of hydrogen is 1, lithium is 3 and sodium is 11. Now you have to write the electronic configuration of these elements. So you know about the electronic configuration. This concept you have already learned in last year. So while writing the electronic configuration, you must know the capacity of shells which was present around the nucleus of elements. See, nucleus. Electrons are moving in the shell which was surrounded by this nucleus, and in that shell there are electrons which was revolving around the nucleus. Now in first orbit you know that there are 2 electrons. Then next orbit which contains 8 electrons. So in first orbit the capacity of the first shell is 2 electrons. The name of that shell is K. Now second shell which was known as a L, and their capacity of electron is 8. That is second shell which contains maximum 8 electrons. Similarly, another cells, that is next cell, which have a capacity 18 electrons, and next, that is fourth shell which has a capacity of 32 electrons. That is, there are 4 types of shells which was present, which was surrounded by the nucleus of element. So first shell, that is K, having capacity 2 electrons. Second shell, that is L shell, having capacity of 8 electrons. Next, third shell having capacity of 18 electrons, and next, that is fourth shell, that is N shell, having capacity of 32 electrons. So this point you have already learned in last standard. So in first shell electronic configuration, that is first shell contains 1 electron, because number of electron which is known as atomic number. So you can divide these electrons by using their electron capacity of each cell. Now lithium having atomic number 3. So in first shell it contains 2 electrons, because the capacity of first shell is 2 electrons, and next shell which contains 1 electron. Now next one is sodium having atomic number 11. So in this first shell having 2 electrons, next shell having 8 electrons, and 2, 8, it means 10 electrons, atomic number 11, then the remaining 1 electron is present in next shell. So in this way we can write the electronic configuration of the elements. Now if you observe the electronic configuration of the elements which was present in group first, in each element you can see that last orbit contain 1 electron. So the name is given as a group first, because in each element, in each elements of group first, in last shell they contains 1 electron, hence the number is given 1. Number is given 1. So in group first, all elements contains 1 electron in their outermost shell. That last shell elements which is also known as a valence electron. So there is one valence electron in all the elements of group first. Similarly, if you can see in group second, see in group second, if you can do a electronic configuration in group second, then you will find what you find. See the elements of group second. First element is beryllium having atomic number 4. So their electronic configuration, first shell contains 2 electrons, second shell contains 2 electrons, that is 4. Now next element, that is magnesium having atomic number 12. Now electronic configuration of this magnesium, first shell contains 2 electrons, second shell contains 8 electrons, and remaining 2 electrons are present in the last shell. So if you can do the electronic configuration of these elements which was present in group second, you will find that there are 2 valence electrons, that is electrons present in the outermost shell. So in these elements of group second, there are 2 valence electrons in all elements of group second. Hence this number of group is 2, because 2 valence electrons are present in outermost shell of each element of group second. Similarly, you can find that in all groups these numbers are given according to their number of valence electron. So if you can see in the group 17, see in 17 group, if you take some elements and write their electronic configuration, you will find that in group 17, see fluorine having atomic number 7, chlorine having 17. Similarly, you can write another elements also. If you write the electronic configuration of these elements, that is elements present in the group 17, first shell having 2 electrons, next shell which contains 7 electrons, because the atomic number of fluorine is 9. So in last orbit there are 7 electrons. Similarly, chlorine having atomic number 17. In electronic configuration, you will find in first orbit there are 2 electrons, in second 8 electrons, and last one 8 plus 2 10, remaining 7 electrons are present in last shell. That is, in every elements of group 17, they show 7 electrons in their outermost shell. So this similarity is found in all elements present in different groups. So they contains same valence electron in their outermost shell. Now modern periodic table and electronic configuration of the elements. In this point we have seen that different electronic configuration of the elements present in groups and periods. So the characteristics of the groups and periods in this modern periodic table are because of their electronic configuration of elements. So the characteristics of this group and period in the modern periodic table are due to the electronic configuration of these elements. So in electronic configuration of element which decides the group and the period in which that element is to be placed. So according to the electronic configuration, the place of element is decided. So this electronic configuration is very important. Also, the neighboring elements within a period. So period, that is horizontal row. The neighboring elements, see, the neighboring elements within the period differs slightly in their properties. While distant elements they differs widely in their properties. So properties of elements, which was totally based on the electronic configuration of elements. So in period, while going from left to right side, their properties shows differences. The neighboring elements within the period, they differs slightly in their properties. See, so in period म्हणजे या पिरियड मध्ये जे नेबरिंग एलिमेंट्स आहे त्याच्या ज्या प्रॉपर्टीज आहे त्याच्यामध्ये काय स्लाइटली चेंजेस आहे. पण या पिरियड मधला फर्स्ट एलिमेंट आणि लास्ट एलिमेंट जो इकडे दाखवलेला आहे त्याच्या प्रॉपर्टी आणि फर्स्ट एलिमेंटच्या ज्या प्रॉपर्टीज आहे या टोटली डिफरंट आहे किंवा त्याच्यामध्ये खूप मोठ्या प्रमाणामध्ये काय चेंजेस आहे. सो दिस इज अबाउट द पिरियड. सिमिलरली elements in the same group, see, elements in the same group, they show similarities and gradation in their properties. So group having similar chemical properties, elements which was present in the groups, they show similar chemical properties, and that properties they shows similarities and gradations in their properties. As we go from top to bottom, we can see that there is a gradation of their properties. म्हणजे त्याच्या ज्या प्रॉपर्टीज आहेत त्या क्रमाक्रमाने काय होत आहे की पुढे वाढत जात आहे. जेव्हा आपण या टॉप कडून बॉटम कडे येऊ त्यावेळेस काय होणार आहे की त्यांच्या ज्या प्रॉपर्टीज आहे त्या क्रमाक्रमाने त्या ठिकाणी वाढत जाणार आहे. So we can see that the elements which was present in the groups, they shows in same groups. Elements in the same group shows similarities and gradation in their properties. So this is the main characteristics of the groups and period. So various properties of all the elements in the groups, they shows similarities and gradation. However, the properties of elements changes slowly while going from left to right in period. While going from left to right, we can see that the elements or their property changes slowly while moving from left to right in period. And in group we can see that elements in the same group shows similarities and gradation in their properties as we go from top to bottom. In modern periodic table we have seen that elements, they are arranged in their increasing order of their atomic numbers. Then vertical columns, they are called as groups, and there are 18 groups in modern periodic table. And the chemical properties of the elements, chemical properties of the elements in the same group shows similarities and gradation. Properties of elements changes slowly while going from left to right, that is in a particular period. While we are going from left to right, then the properties of elements changes slowly. So this concept we have seen in this modern periodic table.
Explanation. Classification of elements. We have learnt in previous standard that all the atoms of an element are of only one type. Today, 118 elements are known to the scientific world. To ease the study of such a large number of elements, scientists started the different methods of classification of elements. In the initial classification, elements were classified into groups of metals and non-metals. Later on, another class of elements called metalloids was noticed. Dauberena's triads. Characteristics of Dauberena's triad. A German scientist, Dauberena, suggested that properties of elements are related to their atomic masses. He made groups of 3 elements, each having similar chemical properties, and called the triads. He arranged the 3 elements in a triad in an increasing order of atomic mass and showed that the atomic mass of the middle element was approximately equal to the mean of the atomic masses of the other 2 elements. Examples of Dauberena's triads. 1. Li, Na, K, lithium, sodium, potassium. 2. Ca, Sr, Ba, calcium, strontium, barium. 3. Cl, Br, I, chlorine, bromine, iodine. Let us try one example. Lithium is greater than atomic mass 6.9. Sodium, atomic mass 23.0. Potassium, atomic mass 39.1. is equal to sum of the atomic masses of first lithium and third potassium element equal to 6.9 plus 39.1. Mean is equal to 6.9 plus 39.1 by 2, that is equal to 46.0 by 2, that is equal to 23.0, that is atomic mass of Na. Demerits of Dauberena's triads. All the known elements could not be classified into the Dauberena's triads. Newland's law of octaves. Characteristics of Newland's octaves. The English scientist John Newland corrected the atomic masses of elements to their properties. Newland arranged the elements known at that time in an increasing order of their atomic masses. It started with the lightest element, hydrogen, and ended up with thorium. He found that every 8th element had properties similar to those of the first. For example, sodium is 8th element from lithium and both have similar properties. Also, magnesium shows similarly to beryllium and chlorine shows similarly with fluorine. Newland compared this similarly with the octaves in music. In the Indian music system, there are 7 main notes, namely Sa, Re, Ga, Ma, Pa, Dha, Ni, and their collection is called Saptak. Like that, the 7 notes in the Western music are Do, Re, Mi, Fa, So, La, Ti. This is the octave of Western notes. Newland called the similarly observed in the 8th and 1st element as law of octaves. Demerits of Newland's octaves. Many limitations were found in Newland's octaves. This law was found to be applicable only up to calcium. Newlands fitted all the known elements in a table of 7, 8, that is 56 boxes. Newlands placed 2 elements each in some boxes to accommodate all the known elements in the table. For example, CO and Ni, Ce and La. Moreover, he placed some elements with different properties under the same note in the octave. For example, Newlands placed the metals CO and Ni along with halogens, while Fe having similarly with CO and Ni away from them along with the non-metal O and S. Newland's octaves did not have provision to accommodate the newly discovered elements. The properties of the new elements discovered later on did not fit in the Newland's octaves.